The Cetacean Acoustic Trend Tracking Project, CATT, uses Chelonia F-pods to track dolphin and porpoise population and distribution activity around the UK. In this video, we are looking at exporting. Here's a file loaded from the Isles of Scilly. We're going to export detection positive minutes per day from file 2, which is an FP3, and we're going to drop that into an Excel spreadsheet. In this case, we are exporting dolphin detections. So we put in the date and the dolphin detections, and we graph those two columns in Excel, and this gives us a nice overview of the detections per day, per minute. We can also go in and do the number of clicks, which gives us a bit more detail. When we look at the clicks chart, we will see it is slightly different. The peaks come out in slightly different places. This is possibly due to data saturation when we look at detection positive minutes. So clicks are preferable if you have data saturation. If we now do the same thing for NBHF or porpoise detections, we can export those separately, drop them on the spreadsheet beside the dolphin detections, and make a new graph that overlays the porpoise detections over the dolphin detections. This can give us some indication of displacement or avoidance. Both sonar detections can be overlaid here too to see if there's any evidence of anthropogenic noise affecting the animals. We can also export detections and environment. This gives us our porpoise, dolphin and sonar detections and puts them alongside things like the temperature and the angle of the pod in the water. This is also one place where we can get the porpoise, the dolphin and the sonar detections all beside each other in one place. So in this section, we exported detection positive minutes, numbers of clicks, we graphed it in Excel, we overlaid the graph data, and we looked at detections and environment. In this section, we're going to look at autocorrelation. So I'm going to load 3 FP3 files, set them all to look at species class, and then I'm going to load those files, select one for action, and then I'm going to go to autocorrelate, which is in the display tab. Once here, I'm going to set it to tides, and I'm going to autocorrelate my detections against tides. And there we can see there is quite a close correlation. Nick has written some notes here of various things you can try for residency, tidal or diel patterns, and different time bases you could use. Exports for third-party analysis tools are a bit more advanced. In here, we can export into a text file or several text files, and we can then analyze that data in other applications. In this example, I'm exporting all the train features from this file and saving them onto the desktop. This happens quite quickly, although I have speeded it up slightly here. And there's the file on the desktop. There are about 8 million characters in that file. In this example, we'll go through the same process, but rather than export train features, we'll export click features. There are quite a lot more of these than there were train features, but we'll put them in a text file on the desktop. And there it is. This one has 145 million characters in it. We can now import these datasets into RStudio as text datasets. This is quite easy to do. They load quite quickly. There's the first one. That has about 35,000 entries in it. Now importing the second larger dataset. This will take slightly longer, but it's still very quick. And there it is, 723,000 characters. So to summarize, we cross-correlated dolphins against tides, we cross-correlated porpoises against tides, we used third-party export for train features and for click features, and then we loaded our third-party exports into RStudio. All the data we gather on the CATT project is open sourced at the Figshare Plus website. The software we use to analyze it is available at the Chelonia website.